So in this video, I'll just briefly talk about winding DC resistance, why you have to wait until the current stabilizes or reaches steady state. So it will take a few seconds to minutes depending on the size of the transformer. The larger the transformer, and because if it has a large inductance, it's going to take more time for the current to reach stability. Because basically when you measure winding resistance, you apply DC, but the thing is that current will not reach steady state right away. It's going to take some time, even if you apply DC. So if you plot the current that you apply versus time, it's going to start increasing, and it's going to take some time before it reaches steady state. So like if we call this steady state, or basically where the current reached stability, it doesn't fluctuate or change it doesn't change a lot. So it's going to take some time. It's not going to happen right away. Because if you think about it, we have, for instance, here's one winding. So we know it has resistance, it has some inductance. So when you apply DC voltage, in this source here is going to have some internal resistance. Also, the meter might have some resistance to reduce the time constant, to help with that, to bring the current to steady state as quick as possible. So when you apply DC, current will flow. Again, if we look at the general formula, so this voltage that you applied, so it's going to have resistance times current plus inductance times the rate of change of current with respect to time. And R is just for the winding resistance. L is the inductance. T is time. Basically, what we want when we say reach steady state, we want this term here to become zero. Then we only have our current times resistance, which is what we're trying to measure. Then it's just Ohm's law, basically. So you want this to reach zero. But the problem is this will depend on the time constant, inductance divided by resistance. For large transformers, inductance might be very large. So it's going to affect how long it takes for the current to reach steady state. So it might take it depends, really depends. Just to get an idea, it might take a minute, for instance, to, probably 5 minutes or even more, or less, it depends. So it depends on the size of the transformer. So one way to reduce this time constant is to reduce this inductance. So one way is by increasing current, because if you look at from Faraday's law, the induced voltage is number of turns times the rate of change of flux with respect to time. Then we know the voltage from this equation here is also inductance times rate of change of current with respect to time. So if you kind of equate the two, what you will notice is to decrease the inductance, you have to increase current, which will increase flux, basically, which will kind of lead to core saturation. That's what you are really after. However, you should not, by industry practice, you should not exceed 10 to 15% of the full load current of the winding that you're energizing, or any winding. Basically, you have to be mindful of that, because you could overheat the windings and cause damage to the windings, if that's sustained for too long. But the meter itself might have some resistance in series to kind of help, because if you see resistance is in the denominator here, so if you increase that, it's going to help with the time constant. But basically when you're measuring DC resistance, you have to wait, until current reaches steady state. It's not changing, basically, because it's kind of like a curve. When you apply, so it's going to take some time before it kind of stabilizes. Thank you.